Hello everyone, welcome to my chemistry channel BL the Short and Sweet in Chemistry. Now I am going to explain the topic that is chemical reactivity. Chemical reactivity, that is which is in our syllabus. The chapter is acid, base and salt, and it is applicable to 10th class CBSE syllabus. Now here it is part 7, and before that also I have explained so many experiments regarding chemical reactions and equation, and also acid, bases and salt. Now you will come to reactive 1, where you will take sodium hydroxide in solution test tube. That means you take a test tube and add sodium hydroxide solution and add phenolphthalein, which is indicator. That means it can shows whether it is an alkali or acid or nothing. That means add phenolphthalein 2 drops to it. That means you take sodium hydroxide test tube and add phenolphthalein, that which is colorless liquid. Then what you will observe? The solution turns to pink. Now here, when add dilute hydrochloric acid to the above solution, then what happens? Because here the color already changes to pink, and when you add dilute hydrochloric acid, then what happens here? They become colorless. Now why? Because now it become acid, not a basic character or alkali character. Now it is a acid. Add a few drops, again you add a few drops of NaOH, then to the mixture, then what happened? The pink color disappears. Are you clear? When you add phenolphthalein to the sodium hydroxide, that is become pink. Before that, phenolphthalein is a colorless liquid. When you add here, it changes to pink. That means it changes to. And now when you add hydrochloric acid to that pink color, then pink color disappears. Again add sodium hydroxide, it becomes to pink. The process is going on by adding acid and alkali. So sodium hydroxide plus phenolphthalein, and that gives pink color. Okay, this is the first. Then dilute hydrochloric acid, it turns to that means colorless. So phenolphthalein and NaOH become again pink color. So reactivity 2, where you can see what is the first reactivity that indicates phenolphthalein in sodium hydroxide becomes pink color. Now in second experiment, you will take water in a beaker and add ammonium chloride solid and swirl in the stir the beaker, swirl the beaker. Then what happens? Now you can observe ammonium chloride, which is a colorless crystalline solid. This is crystalline solid. So what happens when ammonium chloride is added to the beaker which contains water and swirl it? Then what happens? Observation. Temperature decreases. Before that I have explained in part 6, the temperature increases, that is exothermic reaction, but here temperature decreases. Outside beaker you can feel it is cooling. That means here it is simply endothermic reaction. Endothermic reaction is one where heat is absorbed. It is an endothermic reaction where heat is absorbed. See the reaction. What happened? Ammonium chloride and here water, then it gives ammonium chloride aqua minus it. If plus it, then an exothermic reaction. If minus it, that is called endothermic reaction. Then again you see the third activity, that is where experiment say take a small amount of copper oxide whose color is black. Which color is black? And in a test tube add dilute hydrochloric acid and stir it properly. Then what happened? The color of the solution bluish green. Why? Why the color of the solution after heating with the hydrochloric acid dilute? And always remember, if it is dilute, you should dilute. If it is concentrated, you should write concentrated. Then what happened? This formation of copper chloride, where the valence is here charge is +2 and minus 1, and here there is called cupric chloride, which is blue-green color, and the color of this solution is blue-green color. And cupric oxide, that is black in color. In black color of cupric oxide, when treated with dilute hydrochloric acid, it gives blue color. Remember, blue green. Remember, the color is very, very important. Due to color, one can recognize one can see what is the compound and what is the color. Next, come to activity 4, where experiment that is given. Identify an acid and base used to form salt. That means you will see if you see the salt, you can imagine, you can identify. You are sure that this is the hydrochloric acid or this is the sodium hydroxide. Any acid or any base you can see, you can identify when you see the salt. Then how? See here, sodium chloride. Chloride, it comes chloride means surely the right part that comes from acid and left part. This is the right part. This is from acid and this is from this left part. This is from base. So you can sure that if you are dilute hydrochloric acid as acid and base sodium hydroxide, you can see that means here ClNa. The product is sodium chloride. Similarly, if you see potassium nitrate, that means this is our acid part and this is our base part. So you can say base potassium hydroxide and dilute nitric acid. Ammonium chloride, that means ammonium chloride, Cl, the part is Cl minus, that is from dilute hydrochloric ammonium, that from ammonium hydroxide, because we know salt is formed by the combination of acid and base. Zinc sulfate, again zinc sulfate, dilute sulfuric acid and zinc hydroxide. It should be the formula ZnOH whole 2, because zinc has this charge plus 2 and OH this charge minus 1. Inference. What is the inference here? There is sodium chloride, sodium hydroxide, hydrochloric acid. That means here you can see these are the sodium chloride is the sodium hydroxide and NaOH. And here you can say when acid combines with base, they are giving as salt and water. Potassium nitrate, that means acid is HNO3, hydroxide is KOH. Ammonium chloride means ammonium hydroxide, NH4OH, and hydrochloric acid is the base. Sulfuric acid, zinc sulfate and zinc hydroxide. Sulfuric acid formula you know, zinc sulfate, this is the formula, and here zinc hydroxide ZnOH whole 2. Then what is the conclusion? That means acid when combined with base, it gives salt and water. If you see any any salt and the left part that is comes from base and right part that come from acid. From that you can imagine, you can diagnose, this should be hydrochloric acid, this should be ammonium hydroxide. Similarly here also you can say this is the minus 1, this is the plus 1. That means nitric acid is the acid part and potassium hydroxide is the basic part. Then salt acids used and base used. See, copper sulfate, sulfuric acid used and copper hydroxide. Sodium acetate, acetic acid and sodium hydroxide. Sodium carbonate, sodium hydroxide and carbonic acid. That means copper sulfate, what is the formula? CuSO4. CuSO4, copper is plus 2 and sulfate is minus 2. So here sodium acetate CH3, COONA, Na plus, and here special one, the negative part is written from the left side and it comes from acetic acid. This is the minus 1. So sodium carbonate Na2CO3, why the formula like this? Because carbonate 2 and sodium is 1, and now this is the formula. And from this formula we can say what is the acid, carbonic acid, what is the base, that is sodium hydroxide. So it is clear that means what is the conclusion? That salt is formed by the combination of acid and base. From this salt we can diagnose what is that that is the acid and what is that base. When they combine give the particular salts. And thanks for watching my video, and thanks hope you will subscribe my channel BL Das, short and sweet in chemistry, and